Conversational AI software is no doubt the next iteration of no-code, from tools like WordPress to Wix to Bubble and now to AI. This is primed to become the most successful no-code so far. Because the barrier to entry is non-existent, the barrier to entry is just the natural language. But that is not the case with current AI no-code software. Using WordPress as the benchmark or pedestal, current no-code AI software are just overpriced and overhyped template spawners and web app workflow visualization makers at best. Don't get me wrong, they are still useful in creating things like static websites, portfolio websites, API boxes, but when it comes to actual database integration, actual middleware integration, actual full stack integration, or creating full stack website, they fall short. Not because these AI models can't do these things, but because the infrastructure doesn't let them. No matter the budget or the deep pocket these AI companies may have, it just can't happen because the infrastructure just doesn't let them. It will be like trying to fix two pieces of mirror with a bubble gum. No matter how many bubble gums you have, it's still a bubble gum. Let's take a look at how WordPress's underlying stacks integrate and synergizes with each other. WordPress underlying stacks are PHP and MySQL. PHP is a server-side scripting language that was designed to work really easily with HTML, and MySQL is a popular relational database that is straightforward and well documented. Now, because PHP embeds directly into HTML and has built-in functions to interact with MySQL databases, it creates this kind of all-in-one environment. You can write a PHP script that handle both your backend logic and your database query, and it will also output HTML to the client side. So you're now left with a table that looks like this. The PHP is the front end, the back end, and the middleware, and MySQL is the database. Even tools like PHP MyAdmin, that is a UI manager for MySQL database, is built in PHP. Now remember, WordPress is the pedestal, so its successors shouldn't be as complicated or more complicated than it is. On to the current traditional setup. When a user prompts an AI no-code software like Lovable or Bold.new to build a functional web application, it has to do so based on its underlying go-to stack. When it does so, it has to host the front end on a web server, B, host the back end and middleware on a different server, maybe a Node.js server or a Python server, and C, host the database on a different server or the same server with a different environment or a temporary different environment just for the setup. The current traditional AI no-code software is supposed to do all these three things in the same environment of the prompter without breaking immersion. It does A by defaulting to hosting it on a subdomain on its own server or as a URI on its own domain and server, but neglects B and C. Why? Because these frameworks have vastly different environments and can't be coupled together at scale in the prompt environment, or at least without a very high cost implication. Let's take a look at some sites and web apps built by Lovable. So we are going to look at applications and websites built by Lovable, mostly applications, things that needs an integration with the backend or a login logic. So this is lovable.dev, the official Lovable website. And when you scroll down, you're going to see it from the community section that shows applications and websites built by users. We know Lovable is great at making websites, but it's not great at integrating the backend. So without talking too much, let's jump into opening applications that need integration with backend. So we'll start with this. So this is Market Mosaic Online, application built by Lovable. As you can see, it's great at creating the dashboard. Login, no, you can't log in. Let's go to settings. You see, there's already placeholder contents here. So it's great at giving a template, but not building full working application. The application it's not full stack, it's not functional. They are just placeholder content. And this is just a visualization of this application. You're seeing the login doesn't work and the contents there are placeholder. So let's go to the next one, character forge images. So this again is another type of template. There isn't any actual backend integration going on here. You can't sign in. It doesn't work. All these are placed. So this is just a placeholder site. It's not functional. It's just for show. And it's great at doing it. These AI models can create these back-end scripts, but they can't integrate because these environments are vastly different. They are not the same. You can't integrate them on the environment of the prompt. This is Fleet Manager. So the same thing is happening here. You see, I'm already logged in admin@fleet.com. This is not a real functional website. It's another template website that just visualizes user interface and the dashboard. When it comes to the backend, they either use a device cache or placeholder content to simulate the backend and login flow, but never a full functional backend. Not because these AI models can't do these things, but because the infrastructure just doesn't let them integrate these vastly different environments. Now, this is my PSA to current no-code AI software teams or up-and-coming AI no-code software teams. Developers and users who want to build functional web application with basically no barrier to entry. There is a solution. The solution is the Internet Computer Protocol. I won't go into a deep dive on what the Internet computer is. I'll just focus on the part of it that is the solution, which is canisters. Now, canisters are basically containers that hold WebAssembly bytecode, which were compiled from existing code. Canisters hold both the code and state of your application. For example, the front end written in any popular front end framework, React, Vue, Svelte, is compiled into a WebAssembly bytecode and then hosted on a canister. The backend written in most popular backend framework like Rust, TypeScript, JavaScript, and Motoko is also compiled into WebAssembly bytecode and hosted on the canister. You can even have both frontend and backend hosted on a canister. This canister saves and stores the state, both the frontend and backend, either in the same canister or multiple canisters run in the same environment, which is the Internet Computer Protocol. And these canisters can talk to each other using inter-canister calls, which is like an API, but everything is happening in the same environment. This means that you don't have to worry about setting up separate servers or databases or even complicated networking. Everything is unified in one ecosystem. You might be asking me, so how does that work in practice? You're right, talk is cheap. This is Caffeine, an AI no-code software, just like Lovable and Bold.new. But the difference is the infrastructure that Caffeine uses. Caffeine deploys its front-end, back-end, and databases via canisters, thereby giving a fully functional web application with a public link without the user having to put in any technical inputs. Let's see some examples. So this is a community showcase of publicly available applications built using Caffeine.ai. The actual number could be in the thousands. These are just the publicly available applications that the community coupled together. So we are going to see example of functional applications with the full working integration of the front end and the back end. Let's start with this secure notebook application built on Caffeine. I'll sign in with internet identity, no login, no password, and username required, just passkey. So it's loading my notes, and all this is done on Caffeine AI. The user doesn't leave the application. Whoever built this didn't leave the application to put in any technical inputs. So we will create a face note, and then we create our notes. So a note is created, and this actually persists. So if you refresh it, you see it's there, right? So we can check the developer tools to confirm that this is actually saving and loading. So right here, you can see the calls it's making to the canister, the backend canister, right? And you can confirm that this is actually on a canister. There's no shady business here. So we will use a tool, carvebrew.com/cc. Then when we check for the canister, you can see the front end canister. And if we open this link, this is the straight up canister URL. So you can confirm that it's actually hosted on that canister. And then we can also check the backend canister. So using another tool called Candid UI to view the canister. So you can see the backend canister information. So the create notes, the delete notes, the filter by category, get on. So you've seen these are actually hosted on canisters and deployed on canisters. As you can see, Caffeine is the only no-code AI tool so far that can deploy a fully functional web application, not because it is special, but because it utilizes the canister architecture on the Internet Computer Protocol. There are other features that make this solution the best: pricing and the login logic. With canisters, the pricing model is a bit different because you're essentially paying for the resource that your canister use on the internet computer. That means you're paying for things like the cycles that represent compute and storage rather than pay user fees. In other words, you're paying more directly for the actual computing resources you use rather than the number of people using your app. Now, this can be more cost effective, especially if you have a large number of users, because you're not being charged per user. Instead, you're charged based on how much computation and storage your canister uses. The next, login logic. On the internet computer, you can use something called internet identity. The internet identity is a cryptographically secure passkey manager that is a secure way to handle logins. Instead of relying on traditional username and password setups or having to integrate with third-party host providers, you get a built-in authentication system. This means users can log in using passkey, biometrics, or device passwords without having to store passwords or manage a separate identity provider. But that makes the whole login process more secure and also simplifies your architecture because you don't have to plug it into a bunch of external authentication services. So in short, using Canister and Internet Identity Framework can give you a more streamlined and secure login system compared to the traditional methods. Well, you might say, or some of you might say, what about Cursor or Winsoft? Well, that is not a no-code AI software. The actual aim for a no-code AI software is to be a single software that builds a full-stack application with little to no technical input as possible from the user. That is the only way this works as a successor to former iterations of no-code tools. Another thing you might say, the Supabase integration with Lovable for the backend and database, that still needs a user to set up a Supabase environment or account manually. And remember, this only works if there is little to no technical input from the user as possible. So in summary, current traditional no-code AI software tools are said to fail or are on the path of obsolescence unless they adopt this canister approach on the internet computer protocol. Hello, call me Earporter. I've been a web developer for 8 years. I'm ready to work with current teams or up-and-coming startups to help them transition to this solution. I've been working with canisters for 3.5 years now, so I know the protocol at the back of my hands. Thank you.